Okay, so we are talking about NFA and the transition function of a NFA. So, now we are going to discuss the extended how we can extend that transition function over a string instead of a alphabet. So, just to recap, a NFA. So, this is the set of all possible state, this is the input alphabet, finite input alphabet, this is the starting state, this is the final state, this is the subset of Q, and this delta is a function here from cross 2 to the power Q. So, this is the power set of all possible states. So, it is a subset. So, from a given state, so if we are at Q, so delta of Q comma A, if you take a input, this is a set. So, say P 1, P 2, some P L. Some set or Q 1, Q 2, Q r. It can go to Q 1, it can go to Q 2, dot I mean dot Q r. So, this is a Q 1, Q 2, Q r set. So, this is a subset of Q. So, that is why it is belongs to 2 to the power Q. This belongs to 2 to the power Q. So, this is a non-deterministic move. So, we can go to any one of this path. So, this is on the input. If we are at a state Q, if we take a input alphabet A, we can go to many states. So, now we are going to extend this delta to delta hat. Instead of taking a input, if you take a string, how it will extend over a string. So, over a string, as we said, delta hat is a function which is taking Q cross. So, this is also like this. Now, here this is a string. Now, string could be epsilon is also a belongs to sigma star. So, that is the base case, this is the convention, this is as Q. So, this is the empty string or this is also called null string, not empty set. This is a string of length 0, no string I mean. So, that means, if we are at state Q, if you are not taking any input from the input alphabet, we will be at remain that state Q. So, that is the convention, and suppose it is, suppose W is, the W is a string and W is not 0. If W is 0, that is epsilon, that is the first case. If W is not 0, then we are going to define this by inductively. So, how to define that? So, we take a W, W is not 0, W is x a. Now, x could be 0 also, I mean length of x could be epsilon also, but anyway. So, this is A is coming from this alphabet and x is coming from sigma star. Now, we define W hat like this, W hat of Q comma omega, omega is x a. This is nothing but union of delta of P I j A. What is P I j? I will explain, where this delta hat of Q comma x is this set P I j, P k say. This is the way, constructive way we can. So, what is the meaning of this? Suppose we are at Q, we want to read W. So, first we read x, and suppose these are the possible state we can move from x. So, this is delta hat of Q comma x, P 2 like this, P k, P k. So, there are say delta hat of this. Now, we can from here from P 1 we can have a move A. So, A. So, this can be some say R 1 R 2, this is this set. So, from P I, if this is say P I, so this is with the A move, it is all going to delta of P I comma A. So, these are the, so similarly, so these are the all collection, the union, this is basically delta hat of Q comma W. So, we will take an example. then it will be more clear. We will take an example. Yes. So, let us take a simple NFA Q0, Q1 and Q2. Okay, so, this is the starting state Q0 and there are 3 states Q0, Q1, Q2, and from here if we have a one move we can go to here or we can remain here. So, this is 0 or 1 again, and from here we can go to here with the 0 1 move and there is no move from Q2. Okay, so, what is delta? So, this is the final state. What is delta over here? So, delta we can simply write like this. So, we have 2 states, 3 states Q0, Q1, Q2. From Q0 if we see a 0, we are going to Q0 only, and from Q0 if we see a 1, we can either go to Q1 or Q0. So, this is a, we have 2 options, and from Q1 we for 0 or 1 both the case we are going to Q2, and from Q2 there is no move. So, it is a empty set, okay. And Q2 is the final state. Now, we are going to see what are the string this NFA is going to accept. So, suppose we have a W like this, say 0 1 0 1 0 0 1 0 1 0. So, we want to execute this, we want to get the delta hat of Q0 W. So, this we want to see. So, for that what we will do, we will first write delta hat of epsilon, this is Q0, and then we will write delta hat of Q0 1. So, Q0 1 is basically again Q0. So, sorry 0, we see a 0 over here, this one, and then we are reading 1. So, delta hat of, we are at Q0, then we are a 1. So, this we can write in a just a like this. So, delta hat of Q0 1 is basically this is 0 1. 0 1 means now we must read this, this is our x, this is our this. So, it is nothing but union of it is nothing but delta hat of Q0 1, which is same as from Q0 we can go to Q0 or Q1 like this. Okay. Now, we are going to read delta hat of Q0 is 3 symbol 0 1 0. So, this is our W. Now, this is our x. So, this is nothing but delta of, this is nothing but delta of, I mean union of delta of that P1 P2. So, this is our A. So, now this is going to this. So, this is delta of Q0 1, sorry Q0 0, because this is the set, this is the set P1 P2, delta of Q0 0 union delta of Q1 0, delta of Q0 0, delta of Q1 0. Okay. So, now this is nothing but what, from Q0 0 we can go to Q0 only, and from Q0 Q1 0 we can go to Q2. So, this is the set for this Q0 Q2. Now, we take up to this. So, delta hat of q 0 0 1 0 1. So, this is our x, this is our a now. So, this is nothing but now this up to this we know these are the states. Now, this is our a. So, this is nothing but delta of q 0 1, that is the a, union of delta of q 0 q 2 1. Okay. q 0 1 q 2 1. So, now this is again we can write as q 0 1, from q 0 with 1 we can go to either q 0. So, this is q 0 q 1 union of, from q 2 there is no move, this is empty. So, this is same as q 0 q 1, this is same as q 0 q 1. Now, we take this 4. So, that is the last one. So, that let us write here. So, this is nothing but q 0 q 1 q 0 q 1. Now, we take delta hat of q 0 of this 0 1 0 1 0. Now, this is our x up to this and this is our a, and we know delta hat of q 0 x is this 2. So, after, so this is will be union of delta of q 0 0 union of delta of q 0 1. Okay. So, this will be what? This will be deltas q 0 1, q 0 0 is q 0 and the q 0 1 q this is 0, this is q 1 0, because this is the last symbol, this is q 0 0 and q 1 0. So, what is q 1 0? Q 1 0 will be q 2, q 1 0 will be q 2. So, that is the final one. So, this is basically delta hat of q 0 0 1 0 1 0 is nothing but q 0 q 2, and q 2 is the one of the final state. There is only one final state over here. So, then this string is accepted by this DFA, because so this intersection of f is not empty, because it has a final state. So, if it is, if any of the branch is reaching to a final state, then we call this is a acceptance state. I mean the language, this is a accepted string by this NFA. Okay. So, let us just define the language. So, this is clear now. We have many branches, we will draw the branch in a moment, but before that let us define the language accepted by a NFA. Language of NFA. So, suppose you have a NFA q sigma delta q 0 f. Okay. Now, we know this is delta is a function from q cross sigma to the power this, and we have just now we have extended this to the sigma star. Now, we consider all strings which are accepted by this NFA. So, that collection is called language accepted by this NFA. So, this string is, this is written as this is set of all possible strings such that delta hat of q 0 this. So, this is a subset. This subset should contain at least one final state. So, this intersection f is non-empty. So, it should contain at least one final state. then this is called. So, that string is the accepted by this NFA and the collection of such string is called the language of this NFA. Okay. So, now we want to find the language of the NFA, just the last example we can continue, and we want to find the language of that particular NFA. So, just to rewrite the NFA. So, Q 0 is the starting state, we have Q 1 and we have a final state Q 2 and we have a move like this 0 1 and this is 1, this is 0 or 1 and there is no move like this. And just now we have executed this 0 1 0. So, this we have seen, but now we are going to draw the computation tree. Computation tree. So, there will be many branches of doing execute this. So, basically we start with here Q 0. So, from Q 0 we have a 0 input. So, from with the 0 input we can either go to Q 0 or we can go to Q sorry. So, let me write in a bigger way. So, Q 0. So, we can go to Q 0 again with the input 0, there is only one option and from Q 0 again we have a 1 over here. So, for 1 we can go to again Q 0 or we can go to Q 1. Okay. Now, so this is with 1 we can go one of this branch. Now, from here we are seeing a 0. So, if you see a Q 0 will be at Q 0 again, and but from Q 1 if we take this branch, from Q 1 if we see a 0 we can go to Q 2. So, this is the we stuck here, okay, and we hold and reject. So, this because we have to have more input to take, but this is stuck, we cannot go anywhere here. So, this is stuck basically. Okay, STUCK. So, this is stuck, we are stuck. So, we hold and reject this branch. So, we just reject this branch, we will not go anymore on this branch, there is no hope in this branch, because there is no further move from Q 2 to any input. So, we have taken 0 1 0, now we have to take 1. So, if you take 1 again we have two options, we can go to Q 0 or we can go to Q 1. So, 1 now 0. So, if you take the 0 then we can go to Q 0 again or we can go to Q 2 0. So, this is the accepted branch. So, if we can have a one branch which is going to a accepted state, this is accepted state, because this branch has no, because we have already, this is rejected branch. Because this is not leading us to a accepted state. The accepted state is Q 2, but this branch. So, we start from Q 0, Q 0 again, Q 0, Q 0, then Q 1, then Q 2. So, this branch is going to a accepted state. So, from a given string, if there is a branch, there may be many other branch, like this branch is stuck, we cannot go anywhere now, hold. This branch we are completely executing this, but it is not ending to a accepted state. But this branch, if there is at least one branch which is leading us to a acceptance state, then that string is called accepted. That string is accepted. Okay. In fact, this the language of this is this one. It is accepting all the binary string whose second last symbol is 1. Second last symbol is 1. Second last symbol is 1, this one. Okay. So, that means it is like this, even if we have 1 1, then also we go to. So, after this, say suppose if it is instead of 0, if it is 1, if it is 1, then also we can go to Q 2, yeah. So, that is fine. So, this is basically this language is can be written as x 1 A. So, x is belongs to sigma star, A is belongs to sigma. So, I think this is the in L of this is the language of this NFA. Okay. But this is the way we are to. So, if a string has to be accepted, then we should have a branch which is leading to as a accepted state. So, that is the accepted branch. So, if W will be rejected, if there is no branch, if every branch is leading to a rejected state or halt or stuck. So, no branch, if there is no branch which is going to a accepted state, then that W will be rejected. So, we will take some more example. So, we will take some more example. So, some more example of NFA and the computation 3. Like suppose we have this NFA, we have a starting state Q 0 and then from Q 0 we can go to Q 1. This one I think we have seen this picture. This is one move and from here we can go to 0 or 1. So, from here we can go to Q 3 and from here we can go to Q 4. So, this is 0 1, this is 0, this is 0 and from here we can go to just 0 and 1. Okay. So, now we want to see what type of string this is accepting. So, suppose we have a input like this, say 0 1 0 0 1. We have an input like this and we want to see whether it can, I mean it can be accepted or rejected, this string. This is a string W, we want to check whether this W is accepted or rejected. So, we start with, so this is the, so we start with Q 0 and we are going to read this. So, if we start with Q 0, if this is 0, so it can go to again Q 0 or it can go to Q 3. So, we have to mention the final state, this is the final state. Okay. It can go to Q 3. So, once it go to Q 3 and we are having, so this is with 0 move and next input is 1, but there is no move from the Q 3 with 1. So, we stuck here this branch, but from Q 0 again we see a 1, for 1 we can go to again Q 0 or we can go to Q 1. So, if you go to Q 1, then again we see a 0, there is no 0 move from Q 1. So, it is stuck. So, these all are stuck, I mean the halt on this branch. Okay. So, now we can from here what we can go, we can we see. So, this is 0 1 again 0. So, from q 0 if we see 0 again, then we can go to again q 0 or we can go to q 3. So, this is 0. We can go here or we can go to q 3. Okay. So, now these are done. Now, again we see a 0. So, if we see a 0 from q 3 we can go to q 4 with the 0, and from q 1 we are seeing a 0, then we can again go to q 0 or we can go to q 3 again. This is the 0 move. Okay. Now, from again the last symbol is input symbol is 1. Now, with q 0 if we see a 1, then we can go to either this q 0 again or we can go to q 1. This is both with 1, and from q 3 we see a 1. So, there is no move. So, this is stuck, this is stuck, and from q 4 if you see a 1, then we can again go to the q 4 because this is the thing. So, this is the accepted branch. So, this is 1, this is the accepted branch. Okay. So, this is the accepted branch. So, this means this string is accepted by this, because at least we have a one branch starting from q 0, it can lead us to the the final state. Okay. So, we will discuss more on this. Thank you.